non-conducting sphere or uniformly charged sphere, it is given. Now, this is an important part. You should remember, I will not go to a detail of it, very much detail, because it is important for JEE people. Now, if suppose somehow it is telling that there is a charge on the sphere and it is uniformly charged, it is not conductor, it can be insulator, it can be a non-conducting sphere, insulator also, and the charge is present throughout the volume everywhere like this, and then we have to find the electric field. Remember, for this also, outside point will be same behavior. For outside point, E out will be same like this, 1 by R square. No worry, same relation. We have to find only inside point, for inside point. So for this, since the charge is distributed in the volume, so we have to consider volume charge density rho, and it will be charge by, if suppose it is having area of R, then 4 by 3, 4 pi R cube. You remember, this is volume of sphere. Now, if we calculate the electric field for this inside, what we will get? We get at any point inside this, we get electric field is directly proportional to R for inside point. For, let us suppose, any distance from here, I am telling, naming is like this, R in. It is directly proportional to R in, like this. There is derivation also, but I am skipping the derivation. But if you want, I can derive here also. That depends upon you. So for conducting sphere, we can say that it is like this. Electric field is like this. First proportional, increasing with it, and now after that decreasing like this. Outside relation is 1 by R square, and inside it is directly proportional to R in. This is the electric field diagram. You should remember. Any problem till now? If you want derivation, you can tell me. Otherwise, I will skip the derivation because it's not important so much for your NEET exam. Any problem till now? Any derivation you want? Okay, I'm skipping the derivation, so don't worry, because it is not important for the exam. That's why we are focusing on NEET exam. So I'm skipping the derivation. Now, let me discuss one more thing. Now, let me discuss a few more things. One question. Suppose it is given that we are having, suppose it is given that there is a hemisphere. I am taking some question example. Hemisphere, it is a hemisphere having radius R. One charge is placed here Q. And it is telling that find electric flux through surface of hemisphere. You try once. I am giving you 10 seconds to think. It is a hemisphere and one charge is present at the center of this. Here, you have to find the flux through the hemisphere surface of hemisphere. Try. I give you 10 seconds to think. Okay, no worry. Let us discuss here. Now, how to do this question? We will think if it will be the whole sphere like this, because we know that Gauss law tells about the closed surface, not open surface, because if it is a hemisphere, it is the open surface, but Gauss law tells about the whole surface, it is a closed surface, and we call it as a Gaussian surface. And we know that it is E dot dA, that is integration of flux d phi, closed integration of flux, and it gives us enclosed charge by epsilon naught like this. Now, first of all, let us assume it as closed whole sphere, pura sphere. We had assume it like this. It is a whole sphere. If it is a whole sphere, what we will get? We will get flux is equal to charge enclosed. Charge enclosed is capital Q by epsilon naught, and flux will be phi is equal to Q by epsilon naught. But it is not a closed surface, and we are getting it is only a half surface. That's why we have to divide factor by 1 by 2. Since it is a half, we will get what we get, new flux. From here we will get phi is equal to sigma charge by epsilon naught. But if since it is a hemisphere, half of it, and we know if it is a hemisphere, the area will be, surface area will reduce to half. So a factor of 1 by 2 multiply here. What we get? Sigma Q by 2 epsilon naught. This will be the answer. Any problem in understanding this? Any problem? Okay. Now let us move further. Now let me take one example also, and try to give you one question. Now, if suppose it is given that, we are having a cone like this, cone like this, it is having a cone, and for this cone, let us suppose a charge is present here, and you have to find flux through curved surface. Can you tell me what will be the answer? Can you tell me what will be the answer? How will you think? Can you tell me what will be the answer? Zero. Look, calculate from here. Think like this. You can remember. No problem. It was similar if suppose I give you hemisphere like this. Will it be zero? No. Similar concept. We will complete it like this. Similarly, what we will do? We will assume it like this and complete it like this. And we will think that flux is equal to charge enclosed by epsilon naught. We will get flux is equal to charge by epsilon naught. But since it is half of this cone, if we draw one cone, then the charge will get enclosed in a closed surface. So since upper part is not present, we will say flux is equal to Q by 2 epsilon naught. Remember. Any problem? Getting difficulty to understand? Any problem? Facing any problem till here? Any problem? Okay, good. Now, if you got it, one more question, similar like this. I think it is a famous question. Suppose we are having a square of side A. It is a square of side A like this, and charge is present, Q charge is present at a distance of A by 2. You have to find the flux, through this square plate, square surface or plate. Will you try? Try once. Give you 10 seconds to think. Any answer? Can you try? Can you try? Any answer? Can you try? Okay. No worry. No worry. No worry. Not getting any problem. No worry. Now, let us discuss this. What we will do? It is given that we are having this square and one charge here. What we will do to apply the Gauss law? Remember, to apply this Gauss law, what we have to do? We have to close the surface. Then we can apply this Gauss law. And after applying this Gauss law, we will manipulate this flux according to our requirement. Okay, this is the step. So for Gauss law, we have to make the surface close. So what we will do? We will make a cube using this. What we are doing? We are making one cube like this. One cube like this. We are making one cube like this. We have made one cube like this. Okay, cube having 6 faces. Now for this, it is a closed surface. Now it is a closed surface. If it is a closed surface, we can apply Gauss law, and we will tell that integration of d phi is equal to Q enclosed by epsilon naught. Now Gauss law is valid here. So what we will get? We will get flux is equal to Q enclosed by epsilon naught. This is for the cube. Now for one surface here, for this we have to find for this. What we will say? Now we will manipulate according to our requirement. So for one of the square, what we will do? This is for the 6 faces. Cube has 6 faces. For one face, what we will do? We will multiply the factor of 1 by 6 Q by epsilon naught, and this will be our answer.